Hello again. So now we are going to deal with example 3 on topic 7.7, and it's the difference between two squares. So in our previous examples, we had ax plus b right here squared, and we also looked at a minus b squared right here. And we saw that they have a very specific model that they follow. They both follow that they have a squared, 2ab plus b squared, and it depends upon this sign right here as to whether it's a minus b squared or if it's a plus b squared. So now we're going to look at when we can't use the shorthand because they have different signs. So if they have different signs, we also need to be aware that they too are a special case. So what does this equal? Let's put it back in our area model, draw in our box right here. And we have a plus b and a minus b. So in this situation, this first box is the same. It's still a times a, which is a squared. But when we do a negative b times a positive b, it's b squared, but the sign now, instead of being positive, is negative. So you have negative b squared. Now we have a times a negative b. That's a negative ab. Then we have a positive a times a negative b. So that's a positive AB. And we bring it out of the box. We have a squared minus AB plus AB minus B squared. What happens to our center two terms? Our center two terms minus AB plus AB. So that's like a minus 1 plus 1. So they actually combine to equal 0. So what are we left with? We're left with a squared minus b squared. So when you have the difference of two squares, which is a plus b and a minus b, you're going to have the a squared minus b squared. So this is a special case. It's called the difference of two squares. Our example says to factor x squared minus 9. Well, if this is the difference between two squares, then we know this is a squared minus b squared. Doesn't have any middle terms, so that tips us off that it's not the previous two examples that we've already explored, the a plus b, a minus b squared, because in both of those situations you had a positive ab, 2ab in the center, or a negative 2ab in the center. This, you have absolutely no center term. So now if this is a squared minus b squared, then we know that a squared is equal to x squared. So we want to know what a is. To find out what a is, simply take the square root of both sides. The square root of x squared is x. We need to know what b is. So if b squared is equal to 9, then b is equal to the square root of 9, and the square root of 9 is 3. So now we can use our model a plus b times a minus b to factor, because now we know what a and b is, and we just plug those in for our a and b. So x squared minus 9 is equal to x plus 3 times x minus 3. And there you go. The next one that they ask us to factor is going to be 4x squared minus 81. It doesn't have a middle term. So we know that we are dealing with the difference of two squares. We simply set what our a and b is equal to. We have a squared is equal to 4x squared. So a is equal to the square root of 4x squared. The square root of 4 is 2. The square root of x squared, as you told me up here, is x. So our a is equal to 2x. B squared is equal to 81. To find out what b equals, you simply take the square root of both sides. So the square root of 81, if you remember from your perfect squares cheat sheet, is 9. 9 times 9 equals 81. So now that we have our a and our b, no middle term, it tells us that it's the difference of two squares. We can plug it into our a plus b times a minus b model. And so we have 2x plus 9, 2x minus 9. And it's simple as that. To check your work, you can simply plug it into your area model and make sure everything works out fine. What you should notice is that on that diagonal, your two terms are going to cross out. So breaking it down into small chunks where it's easy to factor these very special cases. And don't be intimidated, once again, if your coefficient on your first term is not 1, because as long as you can recognize it's a perfect square, then we can proceed with simplifying our ways to factor by using these special case models that they've given us. One more example coming up. Stay tuned for example 4. You can find it in the next video. Bye, guys.